So the talk I'm going to do is about refactoring, which is a technique that I've been somewhat known for because I wrote the original book on refactoring back in 2000, and I spent most of the last few years writing this, which is the second edition of the refactoring book. And it's always a difficult decision to do a second edition of a book, even a book that's been very successful as a first edition, because you say to yourself, why go back over that ground again? And in this case, I did this because I feel this is a really very important technique, a core technique for software developers. And it was important to make sure that it was explained in a fresh way for new people coming into the profession, because after all, we have new people coming into software development all the time. Just out of interest in the crowd, how many people here just say they do refactoring regularly as part of their work? And how many people here, it's perfectly okay to stick it behind, either don't know what it is or you don't use it because you don't think it's applicable to what you do? No one's prepared to admit it, okay. So, a lot of people put their hands up. It's a very common technique, and so a lot of you are familiar with it. And that always then kind of raises the point with a talk like this. I'm saying introducing refactoring. If you already know about refactoring, why don't you just go out to the bar and have something to drink while I'm speaking instead? And indeed, what use is a second edition book, or even the first edition book, to you? And I always like to think of a book like this, or a talk like this, operates at two levels. The main level it operates at is to teach new people that are new to the subject. That is, if you don't know anything about refactoring, because you've just come into software development, or you've been there for a while and you haven't come across the technique yet, then you get a book like this to learn how to do it. But there's a second level, which is also important, which is if you're experienced at refactoring, you'll almost certainly be involved having to teach new people how to do refactoring. And so my hope is that a book like this can help you do that. So it's a book that may not be directly beneficial for you, but it helps you teach other people. And this is true, of course, of any book like this. It's both useful to you to learn from, but also to help you teach, to pass that on. And so in this talk, I'm kind of addressing the second part more than the first part. I'm going to go through teaching it as if it's to new people, but I'm actually talking to you about how I think about passing this on and how you can help teach it to others. And I'm going to do that by focusing on the very beginning of the book. As in the first edition of the book, I open with an example. And this was actually quite an unusual move when I did it back with the original book in 2000. And several of the reviewers said, oh, I don't know whether it's a good idea to do that. Because traditionally, with a book like this, you begin by talking about the broad purpose and general principles and things of that kind. But I felt with a technique like this, it was better to start with a very concrete example, show people what it looks like, and then in a later chapter, I talk about the broad principles. And that seemed to work. People were happy with that in the book, as it turned out in practice. And so I retained that same structure for the second book. However, I did have to alter the example a bit. The original example was based on the notion of a video rental store. And, you know, if you're young today, you have probably no idea what a video rental store is. By the way, I mentioned the book here. I should also mention that that first chapter that I'm going to be talking about, you don't have to buy the book to get the first chapter. ThoughtWorks makes the first chapter available as a download from ThoughtWorks' site. It's a PDF, and you can just use it and take a look at that. And so you don't have to get the book to follow through with the talk. And I'll repeat this URL at the end of the talk as well. So, I recast. And this is where I hope the font might be a problem towards the back, but unfortunately I can't make it any bigger because I have to fit it on the screen. What I did is I decided to recast the example as performing plays, Shakespearean plays for clients. It's kind of like a video store, but kind of different, right? And it's older than a video store, and will probably last much longer than a video store. That's my hope. And imagine they are doing this and they are sending out bills to their clients, to their performances. And the data that they capture for this is the input data for the program is based on JSON data structures. So this very first one here describes the various plays that they have. And hopefully, as you can see, it describes the title of the play and whether the play is a tragedy or a comedy. Because they do two kinds of plays, tragedies and comedies, because it's Shakespeare, right? And then when they do a performance of the play, what you see is this JSON data structure, where they basically say, okay, I'm doing it for a customer, and for a particular customer I carry out certain performances. Each performance I have a particular play, which is the play ID indicated at the data structure at the top, together with how many people were in the audience, because that's the basis for the billing. And then the program takes these two input data structures and produces this output. A simple little statement, plain text, that says how much cost it is, based on the amount of people who come to see the play. Very, very simple program. And in fact, the entire program is that. Now, again, if you're not focusing on, don't have to focus too much on the details of the program, because you can always look at the book or the PDF later on. It's not a huge program. And at this point, one of the difficulties of any teaching of programming begins to come up. Refactoring is a technique that makes sense with and dealing with larger systems. But in order to explain it, I have to use a program that's too small to be worth the technique. Because if I tried to explain it on a big problem, it would just take too long. And everybody would sort of lose attention and all the rest of it. And I tried some larger examples when I was writing the first book, and they were just too big. You just couldn't hold them all. So as a result, I use a program that's kind of too small to be worthwhile showing this example. But bear in mind that this is an important technique, of course, for a much bigger thing. Now, there are some faults, definitely, with this program that I could talk about. But when it comes to refactoring, one of the things to bear in mind is you don't necessarily want to refactor a program just because it's there. If you've got some code that works, and it's doing its job, and you've got no problems with it, there's no point refactoring it just because it looks ugly. The moment you meant to refactor it is when you need to make any changes to it. Because that's when you need to start understanding how the program works. And if the program is ugly and badly written, it's going to take you longer to understand how it works than it ought to. And refactoring then kicks in, because by refactoring you can both help yourself understand the program and leave it in a better state for future modifications. So the key thing here is refactoring is based on modification. And the reason it's so common, of course, is that any piece of software that is still alive, we're modifying all the time. And I have some whole other talk that I won't go into now, but talks about how this is part of the thing that many people find difficult to understand with programming is we need to write clear, high software that has a good internal quality, not because we just want it to be better, but because it allows us to more quickly add features in the future. And the reason that we want to use techniques like refactoring has to be an economic reason. I've heard people talk about not being able to refactor on a project, and they say things like, we want to refactor the program to make it better, but our management won't let us because they want us to get features out more quickly. That's a very common statement. And they say, we've said, yeah, but we want to be good professionals and refactor so that we're doing a good job. And the manager says, well, that's all very well, but I want you to get features out quickly. The tragedy here is as soon as you start justifying refactoring by saying, I want to be a good programmer, and ignoring the speed thing, you have already lost the argument. And the reason you've lost the argument is because economics will always trump professionalism. But the reason that you want to refactor regularly is because of the fact that you want to produce new features quickly. That's the reason to do it. Refactoring allows you to go more quickly over time. So it's important that whenever you're discussing refactoring with someone and trying to justify it, focus on the economics. Focus on the fact that it allows you to get more features out more quickly. So it's not a case of refactoring all more features, it's refactoring in order to produce more features. And it's really important to focus on that. So what new features are we interested in having for this? Well, here I've got two basic change requests that I look at in this opening chapter. At the moment we have a plain text statement to send to people. But you know, we want to be in the 1990s, so we want to produce HTML. So that's the first need. We want to be able to produce both HTML and a plain text statement, which is, as you'll see, quite an important little driver. The second thing we want to do is we want to deal with more kinds of plays. So I mentioned at the moment that we perform tragedies and comedies, but in the future this troupe wants to perform histories, pastorals, pastoral comicals, historical pastorals, tragical historicals, tragical comical historical pastorals, scene individuals, and poem unlimited. But we won't actually go there in the talk. I put that in brackets because when I timed this talk, it just took too long to do that bit. It's in the first chapter, and you'll see how we do it, and I'll say a few words about it towards the end, but we won't actually cover that here. What we're focused on is producing this statement in HTML. So imagine you've got this thing, you've got to go to this slug of code, written by somebody else, or worse still, written by you 6 months ago. You have no idea what the code does, but you've got to figure it out. And you look at a big block of code. When I look at a big block of code like this, one of the first things I look for is, are there any obvious lumps of code that kind of fit together? And an obvious thing that is a giveaway is when somebody has used some blank lines to separate areas of code. Such as here, where we have a blank line there, and a blank line here, and what's more, or sometimes you get a comment as well, there isn't one here, but you have something like that. And here, furthermore, I've got a switch statement that kind of obviously makes its own block. Whenever I see a lump of code like that, I immediately think of my first refactoring to consider, which is extract function. So if you know the original book, you might know that the original book, it was called extract method. And this is actually part of another change from the initial book to this book. The original book, all the code examples are in Java. And I did them all in Java because at the time, Java was the language of the future. People would say, in the future, all programs will be written in Java. Well, we saw how that worked out. With this book, I had to decide what programming language to use. Would I stick with Java, which is still a hugely popular programming language, or should I do something else? When it comes to writing a book, the language I choose isn't the language I most like. It's the language that I think most of my readers will read. That's why I chose Java in the first place. I didn't like Java back in 1990. I was a small talk person. Yeah, small talk. Any small talkers out here? Ah, it's good. There's one or two. That's nice. So, but I picked Java because most people would read it. For this edition, I decided to switch to JavaScript. It was a close choice. I did consider having multiple languages, showing lots of them, to show you how polyglot I was by having 26 different languages in the book. But I decided that would be harder for the readers. So I wanted one language. It had to be very common. It really came down to Java or JavaScript. And I ended up picking JavaScript because For two reasons. One is there's a lot of programmers out there who will know a bit of JavaScript because they have to, even if they don't program in it all the time. So it's a little bit more familiar than Java in terms of widely understood. But also because Java is very forcefully an object-oriented programming language. JavaScript is not necessarily, you can do objects in JavaScript, especially with the latest 2016, ES 2016 stuff, but you don't have to. And one of the things I really want to drive home to people is refactoring is not a technique just for object-oriented programs. It can be used for any kind of programming language. So having a programming language that was much more wide in terms of its applicability made sense. And that's why I changed extract method to extract function, because it's the same thing, but of course it applies with any kind of function, not just object-oriented methods. Of course, there was a certain sadness with this. I mean, when I went from Smalltalk to Java, I was very unhappy. Moving downwards, but I thought, at least I won't go any further downwards than Java. Now I'm at JavaScript. How do I go further downhill from there? I don't know. Anyway, extract function. What does extract function do? Well, those of you who know the book will know it basically takes that block of code and turns it into its own function. And as a result, we pull that out into its own place. And the great thing there is obviously we shorten the original piece, and we have created a kind of block around that piece of functionality that we put in. A block that was kind of just indicated by blank lines and some conventions now actually becomes part of our program structure. And very important part of this is naming the function to say what this function does. So in this case, I'm thinking it's the amount for a particular performance of the play. Now, as I do this, I bring home the essence of what refactoring is about. Now, refactoring, when I first started talking about it back in the 90s, nobody knew about refactoring. It was a totally unknown word. I often would offer it as a talk to conferences and then reject it because what's this refactoring? Nobody knows anything about it, nobody cares. But like many words that are new and then become popular, it starts to get overused. So we see this with objects, with agile, with patterns, with refactoring. And a lot of people treat refactoring as any change of an existing code base. But that's not the case. Refactoring is a very specific technique. In this case, what we've done is we've made a change of the code, but the code works exactly the way it does before. I mean, yes, there's an extra internal call to a function in place, but from an external point of view, from how you observe how the program behaves, nothing alters. All the tests are at the statement that are at that statement level will still behave the same way if we've done the refactoring correctly. So we use the term, but it does not change the observable behavior of a program. And I refer to this, and I do this through this single transformation, which I call extract function. And I call that an individual refactoring. So when I'm looking at the definition of refactoring, refactoring actually has two definitions. There's a noun and a verb. The noun one comes first. It's a specific change, like extract function, but does not change the observable behavior of the program. Also notice that there's a purpose to refactoring. Its purpose is to make it easier to understand and cheaper to modify. That's why we do refactoring, and it drives what the transformation is. You could make a transformation that preserves behavior for other purposes, and we'll talk about a few of those later on, but when you're doing it in order to increase understanding, that's when it's refactoring. Then there's the verb refactoring, which is to restructure software, but only by carrying out a sequence of these refactorings. So it's not any old changing of the software. It's this very specific technique where each change you make is itself a refactoring. You're never changing the external behavior of the software. And this is crucial to how refactoring works. We do a little thing like extract function and it doesn't seem to do much. But the thing is, because we don't change the external behavior of the program, we're very unlikely to make a mistake. And if we do make a mistake, automated tests should catch that mistake and we'll quickly see what goes wrong. Every little change in refactoring, I always often say, refactoring is a change that's too small to be worth doing, each individual step. But we can string together a whole bunch of these things and make a very big change without ever breaking the program, without ever being in a state where we don't know where things are. Or another way of putting it, if anyone ever tells you, I'm in the middle of refactoring my program and nothing works, the one thing you can be sure of is that they're not actually doing refactoring. Because your program is always working when you're in refactoring, at the end of every single refactoring step. So that's extract function, a simple example of a refactoring. So now I've got a function, I can look at that function and focus on it without necessarily looking at the broader program. And as I'm looking through this, the first thing I do is I look at I pick up one of these variables, the variable that is being returned here. Now it's called this amount because that makes some sense in the context of the broader statement function. But when I look at it in the context of this function here, it no longer really makes as much sense anymore. So my next move, my next refactoring move, is rename variable. I'm going to rename that and rename it to result. Why do I pick result? I have a personal programming convention that whenever I have a variable that captures the result of a function, I call it result, because it's the result of the function. See? Straightforward. And so I apply that all the time on my own code. And that way, whenever I look at any of my code and I see result, I know what it is. It's the thing that's returned as the result of the function. Now, I want to stress that's my personal convention. It doesn't have to be your convention. One of the reviewers of this book is a very well-known person who's often on a stage like this talking about very much the same kinds of things I did. He was appalled by that refactoring. You should never use the word result. It's a terrible name, he said. And in fact, every time I used it in the example, he would scratch around it and say, bad name. Because clearly I hadn't heard the first time, so he had to tell me every other time. Interestingly, like a true software developer, he never justified why it was a bad name. He just called it bad. How many people do we know like that in our work? But the important is, it doesn't matter whether I'm right or he's right. You've got to decide for yourself. Or at least your team has to decide. What are your naming conventions? What are you going to follow? Because coming up with good naming conventions across a team has this great benefit. If you all call the result of your functions result, then whenever you see result, you know it's a result of the function. You could call it value, perhaps, if you prefer value. Fine, as long as everybody's doing it and it's consistent across the code base. It also means if you're doing something other than result and I come into your team, I have to adapt my style to match yours. Because I'm now part of the team, I have to fit into team style rather than my personal style. I might use result at home, I use whatever it is I'm working on the team. And you have to do that same adaptation as an individual as well. Because what you want is a consistent style across the team. Naming, formatting, things like that. Formatting we can enforce through linters, naming is a lot more difficult, but again you want that consistency. And that consistency goes as to how you construct statements as well. It's common in Java, for instance, to always have get something and set something for getters and setters. If that's your convention, follow it. And it's a good convention to use in the Java world. You'll notice I don't use it here in JavaScript because that's not the convention there. Anyway, so pick your standard and operate with it. What's next? Okay, so I'm now going to look at one of the arguments, perf. Well, I can kind of guess that's short for performance, but I'm always suspicious when I see any kind of shortening names. Sometimes it's okay, but again, it depends on the context. I want to communicate what's going on here. Perf doesn't really provide that, particularly within the context of this function. So again, I do a rename, but before I do it, I need to figure out how it's being passed in, because this is a value that's coming from outside and being passed into it. So I look at the context, I see about how it's used in the broader program, and I say, okay, it's been passed in because it's something that's going through a loop. Perf then makes more sense as a loop variable, because I often I'm comfortable with shorter loop variables, because they're only using the small section of the code. But I want something better for the function, so what I'm going to do is I'm going to change it to, again, a personal convention and call it a performance. Again, this is a personal convention, it might not be yours. What I like about this is that it indicates the type of the thing being passed in. JavaScript is not a static type language, there are no static type checks. And as a result, I think it's useful to show the type of things by the argument names of functions. And so that's my preference. If I was working in TypeScript or Java, I would do something different because the type would be there as part of the function signature. But since it isn't, I like to put it in. And I use performance. This is an old Smalltalk habit. The old Smalltalker will recognize this. Because you're stressing the fact that I've got an instance of a performance, is what I'm representing here. I don't see that convention being heavily widely used, but hey, I get to write my own book, so I use my convention. I find it a very good convention, so do consider it. I quite like it. So that's what I do here. Then the next one, where are we? Is to look at plays. Did I accidentally double click? Yes. So we have play, which is a bit more obvious. I might change it to a play. But again, let's look at the context. Where is it being used? So I look at this and where it's being used, and now something else is triggering in my mind. This is a variable, a local variable that's being initialized as part of the for loop statement based on some piece of computation. Now, when I'm working on a big block of code, even if it's hundreds or thousands of lines, and I need to break down big functions into small functions, temporary variables are a real source of problems. Because temporary variables tend to make refactoring more complicated. We've seen a little bit, we see it a little bit here because we're having to pass a value into the other function. But as the program grows in size, temporary variables tend to often get in the way and make each piece of refactoring more complex. So my preference is whenever I'm breaking a function down into pieces, or in this case, just trying to understand what the program does, I like to actually get rid of temporary variables as much as possible. So the refactoring I'm going to apply is called replace temp with query. This is exactly the same name as it was in the first edition. So what does this mean? Well, the first thing I do is I extract the right-hand side of that assignment into its own function. And this is a very trivial refactoring, it seems, and the function is tiny. One of the things that is certainly part of my style is I'm not afraid of tiny, tiny functions. The function call overhead in modern systems is tiny. I'll always replace a bit of code with a function if I felt it is of some advantage. And often that advantage can be simply naming. In this case, that doesn't really matter so much, but as we'll see, it's necessary for the next step. So, the first thing I do is I take the left-hand side and take it out. Then, the next thing is I'm going to apply another refactoring inline variable. So, this is a point that's important. Often refactorings consist of other refactorings. So you'll find one step in a larger refactoring is its own refactoring itself. And you often find that these larger scale often you'll have larger scale refactorings which are composed of smaller refactorings. And that's quite normal. In this case, we're doing a little bit of something and then we're using another refactoring. In this case, inline variable. What inline variable does is very straightforward. It replaces the variable with the call to the thing that sets its value. Now, when I do this and when I show this, I usually get all sorts of murmurs of disquiet. There are two things to be wary of here. One is something to be genuinely wary of, and one is not. The thing to be genuinely wary of is that when you do this, you've got to make sure that that variable is not going to change during its usage. And here, we're pretty okay because it's actually not put into a constant. And although constants in JavaScript aren't anywhere near as constant as I would like them to be, because I'm a big fan of immutability, and immutability in JavaScript is a sort of hope rather than anything else. You are actually getting away with it here. And of course we can look at the implementation of that playful function and see the fact that it is actually not have any side effects. But whenever you do this, you've always got to look, is there any side effects on the variable that I have to pay attention to? That's a genuine concern. Make sure you have that straight. The second concern, which is actually the most common concern, is the one that I don't have. I feel is usually a needless constraint, and that is when people say, oh, that's going to hurt performance. People have seen that, heard that when they come across this kind of refactoring. Oh, I'm calculating this thing 3 times now, when before I had to calculate it once. That's going to slow down the program. Whenever you have some concern about performance, if you're going to do anything about it, you have to test it. Run the program before and after the change. See if there's any significant change. Almost certainly, there won't be one in a case like this. It's a dictionary lookup, right? They aren't exactly slow. Performance is really important. Systems require a certain level of performance to be effective, and a hell of a lot of programs do badly when they're slow. The trouble is, there are 2 ways to achieve, 2 techniques that people use to try to achieve good performance. One is terrible, and one is the right way. The terrible way is to, whenever you see a situation like this, to say, oh, I don't want to do that because it'll slow down performance. When you really only have a very vague intuition of what is fast and slow on the machine, and even experienced programmers' intuition is usually wrong. So if you've got some intuitive reason to say, I'm a bit suspicious about this, don't listen, because you've probably got it wrong. Even if you're as experienced a developer as I am, you make mistakes when it comes to performance things. There's a much better way to get good performance. The way you get good performance is, at the first point, you create a good testing environment for performance testing. A realistic environment that allows you to see how does the program perform under realistic conditions. That's actually quite hard and requires significant effort. For instance, if you're building a system that's going to have multiple users hitting the database, you cannot performance test that system by using one user and doing performance tests against the database. Because most of your performance is going to be contention between multiple users. So you have to have multiple users in order to test that contention. So setting up a decent test environment for performance testing is a significant amount of work. It's worth it, you should do it, but don't underestimate how much it is. The next thing is, whenever you're concerned about performance, the way you go about doing it is you start by profiling the system under some typical interactions.